التقديم. Good evening, everybody, students, engineers, and everybody. Welcome to this evening, the end of Ramadan. Eid Mubarak for everybody, and hope that you will enjoy our lecture for tonight. That we have to talk about well control for both drilling and well intervention. This lecture is introduced by me. I am Engineer Sam Shukri, and under the custodian of University of Misan SPE Student Chapter and Hadramaut University SPE Student Chapter. Last week I introduced myself, and within 1 minute I will introduce myself again. My name is Sam Shukri. I am petroleum engineer since 1995. I am Turkish. I have more than 25 years of experience in workover, well services, production engineering, well integrity, IWC certificate, IWCF certification, international instructor. I am authorized from UK, Scotland. I worked for several companies such as Syrian Petroleum Company, Syria Shell, Abu Dhabi ADCO, and instructor for both IWCF and oil and gas. Here, I started here, then moved to here, then moved to here, then IWCF. These are my training certificates, the training certificate #1 in the world. Here, if you want to find some useful issues in Facebook, LinkedIn, YouTube, also this is very important for you. Every day I put videos you can utilize. You can see my name here in YouTube and subscribe and like to allow you to receive any new video that I publish. This is my email if you have any question, and WhatsApp. And here what I work. Here we will start with our lecture for today with agenda, then introduction and definition of well control, types of well control based on type of operation, certification, training and organizations, IWCF and IADC. What's the difference between them? The training levels. We have 4 training levels for both IWCF and IADC. Subjects to be studied and then assessed. Certificates validation for each level, level 1, then level 2, level 2. Also, we will talk about it: objectives, course contents, admission requirements, certificate sample. Also, we repeat the same for level 3 and level 4. Here we have IWCF well intervention. We will talk about drilling and well intervention. Well intervention, we have program objectives, training levels, program structure, certification, principles and procedures, courses, course contents, well life cycle, and well control. So this agenda will talk about completion afterwards. And then we will move to typical permanent completions, barrier principle, hydrostatic barrier, types of barriers, then completion components. We'll take them one by one. Then gas lift system, then well kill methods. We have four kill methods. Then kill charts. We'll explain about them. Even if we take more time, no problem with you. Now you are ready to receive information. We will talk about hydrates that can plug the tubing and for flow line. We'll talk about wireline intervention, the types of wireline, wireline pressure control equipment. Then we'll move to cold tubing operations and the pressure control equipment, open and close SSD in the horizontal section using cold tubing, then well stimulation, hydraulic fracturing, then exam samples. I will give you the same exam questions and answers that come in the exam. So at the end of this session, you will have excellent view about what is going on, about well control. Let's move on to the first item in our session for today. So what is well control in the oil and gas operation? Well control is the technique used in oil and gas operations such as drilling, workover, well completion, well intervention, for maintenance, for maintaining the hydrostatic pressure and formation pressure to prevent the influx, unintentional influx from the reservoir or from the formation to the surface or to another formation. So this is the definition of well control. But how can we achieve this well control? Now, I will tell you something after the incident happened in the Gulf of Mexico, this one, in 2010. And after 11 people were killed, and after escaping 4.9 million barrels of oil in the Gulf of Mexico, that was a big disaster, happened and remained for 87 days. The well is flowing to the ocean, to the Gulf of Mexico, and 11 people were killed. 20 plus people were injured. Huge damage in the equipment, environment damage, equipment, money loss, reservoir damage. So all of these due to uncontrolled. The well flowed and without control. So this is the reason. We will talk about the reason, and I wish all of you to take certificate. By the end of this session, you will know tomorrow, if you write down that you got this certificate from IWCF itself. I will tell you, it is free. You will not pay anything. But for others, you have to pay $1,500. But this one, if you take it, you will feel confident in yourself. And I will tell you how to get into the system and how you can get this certificate and add it to your CV and your portfolio. Let us first listen to what happened with this Macondo incident, deep water drilling well in 2010, and how did they control it, and what afterwards the International Oil and Gas Organization decided that everybody is included in this operation, drilling and well intervention, should have well control certificate. It is mandatory, no compromisation. So you have to prepare yourself. If you want to work with oil and gas companies, you have to take these certificates, and I will explain to you what are the levels. Level 1, awareness. Level 2, introductory. Level 3, operator or driller. Level 4, supervisor. So each one has its own responsibilities. So please focus on the video and listen carefully. You will know why we are here and why this certificate has become mandatory.
The Macondo tragedy, which resulted in the loss of 11 lives, as well as major environmental and economic damage. The International Association of Oil and Gas Producers recognized that all who are involved in any operation during the life cycle of a well in any way should have training to understand well control. The oil and gas industry operates across a global network, encompassing a vast variety of professions and personnel. It is not only those who work on the rig floor who must take responsibility for safe operations. It may be that someone working on the periphery of the industry lends support or understanding after the crew has had a difficult trip. It may be that someone working in logistics goes the extra mile to ensure that the correct people and equipment arrive on site in good time.
This means not only the man who is on the rig or on the well that he has to take this certificate. Look at this man. He is driving road tanker. He is moving liquids and fluids to the well site, even though he has to be aware what is going on. This man, he is in the main office of the company, and this girl also, she is watching what is going on the well. She has to have her own well control certificate.
Whether an experienced individual or a newcomer to the industry, everyone's input and decisions can have a significant impact, not only upon their immediate colleagues, but also the environment and the safety of personnel across the industry. The International Well Control Forum, in cooperation with Oilenium, has produced a free, self-enroll e-learning program to give a knowledge and understanding of the processes that take place during a well's life cycle. While by no means exhaustive, we believe the program will provide people with a broader awareness, which will make their career in the oil and gas industry safer and more rewarding. Over 7 modules, the program describes the life cycle of the well, shows the different types of drilling rig, explains what well control is, describes how we monitor the well, explains what well interventions and workovers are. In the first 2 weeks of its launch, more than 2,000 individuals from over 1,000 energy sector companies in nearly 100 different countries enrolled on this course and took a step towards a commitment to protect the environment, our industry, and all those who work within it.
Clear? I think it is clear. So everyone, even if he is a new, he is old, he has a good experience, little experience, everybody should have his own certificate. It depends on what is he going, what is his role in the operation. Is he supervisor? Is he operator? Is he driller? Everything. So it is included. So everyone has a syllabus. Imagine if we don't control the well, same as what you have seen in the Macondo incident, which is the most dangerous incident that this huge volume of oil escaped from the reservoir to the environment. This incident, 4.9 million barrels of oil escaped from the reservoir to the Gulf of Mexico. It killed the life there. No fish, no whale, no nothing. Even it arrived to the southern coast of the US. In this case, what happened? All animals were killed. We have a big disaster for the environment, the sea environment, also the coast environment. Also, BP, British Petroleum has paid huge money to the US government. We lost the reservoir, the control. We drilled 2 wells, relief wells. So too much due to small mistake in the well control. So it became mandatory for each one to get this certificate and to take his correct action in case of any incident. So if you imagine, if you lose the control on your well. What will happen? You see this one. We lost our control. There is work over here, and we lost our control. What happened? You see, this is gas and oil. Look at it. Imagine that there is a spark here, and it is firing. What will happen? So very dangerous. So everybody has to take his own action before we reach to this limit. This limit is very dangerous. Imagine if there is H2S here. What will happen? If you smell a little H2S, you will be killed. H2S is a silent killer. So we have to put our procedures in place and implement it and avoid such incidents. This incident it doesn't have H2S. If H2S there, something different will happen. If fire is there, something, so the hazard is very high. The hazard is very high. So they decided, the international associated of oil and gas producers, they decided everyone has to have his own well control certificate to prevent such incidents. This is losing of well control during drilling. This is workover drilling. Here also on well intervention, you see here the primary barrier is leaking here, or there is leak from the coil tubing pinhole. So either this or this, but there is what? There is loss of control, losing of well control during well intervention. So we are dealing with the drilling phase and well intervention phase. You see this gas also, it is escaping during night. A spark, small spark, it will make disaster.
Yeah, it's not good.
Okay, it is like this. Here we will talk about these two sections. This is during drilling. This is during well intervention. During drilling, when we drill a well, there could be losses either to from the well well from here to the formation or vice versa. So we may expect that oil and gas will escape and percolate up in the well here to the surface. What will happen to the hydrostatic head? This one, drilling column mud, or we call it drilling fluid. What will happen? Its hydrostatic head will be less. If it becomes less, then the flow from the reservoir to the surface will increase, and we will have kick. This kick will lead us to blowout. Blowout, we will see what we have seen in the previous video or videos. So we have to take this into consideration. So we have two opposite forces, from up to down, which is coming from the drilling fluid or drilling mud, and from down to up, which is from the reservoir. So here should be calculated this one and monitored continuously. So this is called a primary barrier, the drilling fluid. Primary barrier should be monitored all the time and maintained. Otherwise, we will not consider it as a primary barrier. Here we have in well intervention mainly wireline and coil tubing. Coil tubing, here we have external primary barrier, which is called stripper, this one, and internal primary barrier, which is installed at the end of the coil tubing, which is called double flapper check valve in the BHA. So these should be known for us, and we have to keep them primary. This one here, BOP is secondary, and shear seal BOP will be tertiary. So if primary barrier has failed, what will happen? We have to fix it after using the secondary barrier. If secondary barrier has failed, we have to use the tertiary barrier to secure the well. So this is very important. We have to know the primary theory, the barrier theory. This barrier theory will tell you which is the primary, which is the first line of defense. Secondary barrier will tell you which is the second line of defense. Tertiary barrier, which will tell you which is the third barrier of defense. So each one will be used. If one is not working, we go to second. Second not working, we go to third, and so on. So we will talk about drilling. We will talk about well intervention. Here we have International Well Control Forum certificate for drilling. Now, gents, we have two types. Focus with me, please. Two types of well control certificate. One is called IWCF, International Well Control Forum. This one. This, most countries of the world, Europe, Africa, Asia, and other parts of the world, they depend on this certificate. International Well Control Forum is issued by the center in Aberdeen, in Scotland, UK, United Kingdom. It is very tough and strong, and not everybody can pass it. But by the end of this course, if you pay attention and you can understand me what I am talking about, at least you will have knowledge about 30 to 40%. So if you study more and more, I will be guaranteed that you will pass it easily. And I will give you examples of the exam that is given in normal situation. So just I want you to focus and listen and watch what I am talking about. I give you the summary of it. You don't need to go into details here and there and there. Only focus on this lecture, and I am guaranteed that it will be very good starting point for you. So we will talk about this IWCF forum certificate, which is from Britain, and the other one is called IADC. Where is it for IADC? International Association of Drilling Contractors. This is the abbreviation of it. International IADC, International Association of Drilling Contractors. This certificate is issued from Houston, from Texas, in the United States. It is mainly focusing on the US, the fields of US, and sometimes they ask it in the Saudi Arabia. These two areas are only, but this is more difficult. IWCF, it is more strict than IADC. So if you pass IWCF, I am guaranteed that you will pass IADC, because it is a little bit easier than this one. British is more difficult. They focus and they sometimes will play with words, especially if it is not your native language. So they can play with you in some tricky questions. So you have to know English and you have to know the technical, and that is not easy at all. But most of our students pass this exam with high marks. So please focus with me and listen to what I am talking about. So you have to study, we will talk this IWCF for drilling section. We have a drilling and well intervention. I will start with the drilling. A drilling, you have three sections: equipment, principles and procedures, and simulator. And you have four levels: level 1 awareness, level 2 introductory, level 3 drillers, and level 4 supervisors. So by end of this month, I am optimistic. By end of this month, all of you should show us your level 1 awareness certificate. So you put your foot in this section and we'll start up. You will start up your engine, and then you move to level 2, then you move to level 3, then you move to level 4. So I will give you the information for level 4 to prepare yourself. So when you go into the system and study and do exam for level 1 awareness, you will see it as if you are going in a journey. So it will be very easy for you. So I need you to pass it and take this certificate. They give you the exam course and certificate for free. Here we have, in order to prepare for this international certificate, you have to study the following. For this well intervention, we talked about drilling, now we talk about well intervention. You have to study 5 subjects. We have 2 subjects mandatory, compulsory, which is completion equipment and completion operation. You have to do exam for these 2. Plus, you have optional 3 subjects: wireline operation, coiled tubing operation, snubbing operation. So either you do this one plus 2, this is mandatory, plus this one, or you can add, instead of wireline, you can do coiled tubing. So if you are coiled tubing supervisor or operator, you do completion operation, completion equipment, and coiled tubing operation. Enough, you can work. But if you want to work as wireline supervisor or wireline operator, in this case, you have to do this this exam and this exam. Now, if you want to work wireline, coiled tubing, and snubbing, snubbing is similar to we call it hydraulic workover. So but it is rarely used in our region. Only in Algeria, I know that it is used. Other countries, it is not used. So rarely you can find people. It is easy, but if you don't see it, how can you imagine that this is the snubbing? This is the VAR, this is the BO, but I have never seen it. So how can I improve myself? So, but wireline and coiled tubing, everywhere you see them, especially in Iraq, Saudi Arabia, UAE, Kuwait, all other countries. You have to see these, plus completion, normal. The well without completion cannot be producing. Also, we have 4 levels. Awareness, level 1, you have to do it. So you have to choose where shall you go in your career for the future. You have to go in the drilling direction. You can do level 1 awareness for drilling, previous one. This one, you see drilling, you do level 1 awareness. Otherwise, if you want to go to production engineering or well intervention or well services, or whatever you call it, different names for the same duty or position. So you can do level 1 awareness for well intervention. But they call it well intervention in both IWCF and IADC. Here, if you go up, you will go to level 2 introductory. Level 3, you go to operators, and level 4, you will go to supervisor. So it is similar for well intervention and drilling. Here for IWCF International, it is based out in Aberdeen, in Scotland. So the IWCF sole focus in well control. They don't have anything except training on the well control. This is their duty. This is their business worldwide. And not everybody can easily take an accreditation and be as a training center. It is very strict. You have to pay money. You have to have your own manuals. You have to have your own place for training. You have, so it is not easy. So it is expensive because everybody should pay. At the end, you will see who needs to get this certificate. He has to pay $1,700 for this certificate, or 1,500 if there is discount. So it is not cheap, and it is valid this for level 3 and 4 for 2 years. So imagine that you work for a company, and after 2 years you have to redo this course plus do the exam, and you have to pay this amount another time, 1,700 or plus minus. So imagine if you don't pass it. Also, if you don't have enough knowledge, you will not pass normal. So you have to train yourself. It is a good chance. You are very lucky now to find somebody to tell you what is this, what we are meaning with these expressions, what we are meaning with IWCF, with IADC, with level 1, level 4, level, and the certificate expiry date. And this is IWCF, which is in Aberdeen, is more focused on European, you see European, Asian, and Middle East markets, Middle Eastern markets. So this is almost the whole world except US. While consequently the IADC, which is the International Association of Drilling Contractors, this one, International Association of Drilling Contractors, is based where? Is based out of Houston, Texas, in the United States. While it has a global reach and is constantly working to expand this reach. They try to expand this reach to outside of the US. So the IADC is primarily focused where? On the United States. But they try to go to Europe, to Saudi Arabia, to Middle East. As a result, for many US-based land drilling contractors, IADC well control is used almost exclusively. So if you want to work in the US exclusively, you have to have IADC, either drilling or well intervention. It is clear for you, I think, now. This one is IADC, International, the abbreviation, Association of Drilling Contractors, Houston, Texas, USA. Here, IWCF, International Well Control Forum, IWCF, Aberdeen, Scotland, United Kingdom. So this is the logo for it, and this is the logo for it. You are familiar now. Where is Aberdeen? This is Aberdeen. In the northern part of UK, here is England, and here is Scotland, and here is Aberdeen. This is the North Sea. I visited this area here. I went to Holland, Shell company, studied there. So I saw this North Sea. It is a huge and terrible sea. On the other side, this is IWCF. On the other side, we have IADC. This is Texas here. You see Texas and Houston. This is Texas State and Houston City. You see? Let's move on to the next slide. They use different names for course levels. Both IADC and IWCF have identical levels. So this has 4 levels and this has 4 levels, same. Both organizations in the well control training world recently made fundamental change to their structures based on recent report. I told you there is report from the International Association of Oil and Gas Producers, this one. After the Macondo incident, they put outcomes, and these outcomes you have to comply with them. Otherwise, you are not allowed to work anywhere in the world, either drilling or well intervention. So you have to stick to them. Oil and gas. This is Oil and Gas Producers Association. This is a global organization. The means may be slightly different. Both organizations, IADC and IWCF, offer the following levels of training. Same. Level 1, awareness. So if you take it from IWCF, it will be stronger for you. And it is free. You can take it within this week. If you have a tour, you can make a tour or visit it and see what is inside it. Then you can go to next level, level 2. This one you have to pay money. You don't need it just now because you are maybe in the university. But if you are working in an oil company, then you have to have at least level 3 for a driller or for operator. Then supervisor level, which is level 4. So for me, I train all these levels, and I can give you some support in them during this course or in the future. Here the subjects to be studied, then assessed. For drilling, we talked about it, equipment, principles and procedures, and you have a practical assessment. There is something called simulator equipment. As if you are on the rig side, you have to do this assessment and your result will appear straight away. But for well intervention, you have to study 5 or 4 or 3 subjects. I told you which is mandatory or compulsory completion, equipment plus completion operation. You have to do these 2 exams, no way. Then you can choose number 3 or number 4 or number 5 or this plus this or this plus this, whatever you want, you are paying. You can take the certificate. So you can choose what you want before the course starts. Here, drilling level 1, it is awareness. It is a 4-hour classroom-based course currently. So you will do this course for 4 hours. There are videos. You can just watch the videos, and there is a question and answer at the end of each chapter. So the total is 4 hours, and the answers are very easy. So I will tell you how you can get it, but it is 4 hours classroom based course currently included in a 3-day essentials, but now it is done online. A drilling technology and equipment course, but also available as a standalone course for groups of 6 or more. So this is face-to-face, but nowadays it is online. So you can do it by yourself. Level 2 training consists of assessment. If passed, then the certificate will be for 5 years valid. Level 3 and 4, you have to do 3 assessments, and then the certificate will be for 2 years. Here, level 1 well control awareness training was introduced in 2015 as part of an industry-wide initiative. So it covers what does it cover? It covers basic well control concepts and is included in Aberdeen Drilling School's 3 days essential of drilling technology and equipment course. Here, to register in level 1, you can keep this email with you. It is very easy. Level 1 at wcf.org. You will see it in the video at the end of this course. You will keep your video with you, and you will see that you can pass it easily to the website of IWCF. You see, if you write this, I took a snapshot, you see it, www.iwcf.org/programs/level1/DS. You will see this one. It will tell you where to go, group level 1 course. So you can go through them, and you will see that it is easy. They tell you how to go into this level, how to get your, you see, register today. This is the website of IWCF. Register today. If you want to use the email also, they can guide you. So it is very easy. Here, level 1 also, what does it include, and the validity, and so on. Successful will, so all of these, we took them. Here, you see this certificate. Every one of you should show us by end of this month this certificate. It is easy, either for drilling or for intervention. You see here, this is to certify that Steve Ben Orlo has successfully completed the level 1 program. And here is the signature of the CEO of the IWCF. It was issued in end of 2018, and it has a number also. You see this one, number, certificate number, BODIAB, and so you can take it with you. Here, drilling also, we will talk about drilling well control level 2. So this introductory course provides the drilling personnel with basic understanding of well control. Here you have to dig deeper, but if you don't go to level 1, you will not be able to go to level 2, then level 3, then level 4. So it is like a building. This, you build this one above this one. So the science is a structure. If you want to jump without base, in this case, you will fall down, and your neck will be broken. So you have to build yourself, and it is good chance that you are a student at the university and you are building yourself early, especially if you improve yourself in English, you improve your knowledge, you work on yourself. Then all companies, or most companies, reputed companies, will pick you up, will choose you, will give you a better salary. In this case, you will gain the competence. Here, the background, he has a solid background and knowledge of why. Here, he has to be responsible. Now, in awareness, you are not responsible to do anything. But here, he has to be responsible for well control. He has to open, to close. He has to do something during incident scenario. How well control is maintained. What the indicators are if the well control might be lost. So he has to make his brain work. And how to regain if you have incident or well control case, how to regain this well control in case it has been lost. Here also the objectives, you can go through them for yourself, because you have to go from level 1 in the future to level 2, from level 2 to level 3 to level 4. So just for your information, please. You see course content, this is for level 2. Here also, the assessment exam, there is normal exam here. They have to give you certificate for 5 years. The validity is 5 years. So this 5 years, you have to be competent. You have to do surface equipment for 1 hour and 10 minutes. Surface principles and procedures, 1 hour and 45 minutes. Then combine surface and subsea. This is for offshore. Also same time. Here combine surface and subsea principles and procedures, same time. This one, sample of level 2. You see, this is temporary. So after you do the exam, they give you a temporary certificate. It is valid for 3 months. After 3 months, it will be expired. You have to take the normal one, which is for 5 years for level 2. For level 3 and 4, it is valid for 2 years. You see, his birthday, it is written here, 1988. Here, the certificate number also, candidate ID, CR, this one, and the CEO, Chief Executive Officer of the IWC. So it is formal, and it allows you to work in any company, a reputable company in the world. Here we have also the level 3. This level 3 objective also, now you dig deeper for level 3. The IWCF, here drilling well control, we call it, level 3 course, has been designed for whom? Who can attend it? Anyone expected to shut in the well, such as drillers and assistant drillers. So everyone has his own function or position or responsibility. So this level 3 is for drillers and assistant drillers. The course aims to reinforce and improve the candidates' existing knowledge and appreciation of the various stages of shutting. So the well should be shut in case of kick, in case of blowout, like this. So the engineer or supervisor by himself, he will do nothing by himself. He needs the driller, he needs the assistant driller, he needs other people to help him. Otherwise, he will lose the focus and will not do his job properly. So everyone on the well side has his own responsibility, and he has to know what is going on and to take a quick action in case of any kick or any blowout. Here also we are talking about it 5 days course. This is level 3, same as level 4. And here we can continue it is valid for 2 years, and you have to do assessment. You see, level 3 training may be partly combined with level 4. So in many cases, they are very similar, level 3 and level 4, but level 4 is more advanced. So with the level 3, they give you 26 questions in well intervention, while in level 4, they give you 28 questions, another other 2 questions additional. For also other materials, the same. And the same validity also level 2 and level 3 and 4 for 2 years. You see, for 2 years. Here we have also the time for the exam. You see it, 1 hour and 45 minutes. This is for principles and procedures. While for equipment, it is 1 hour 10 minutes. Here for working in the subsea offshore. Here is the sample of certificate. Also, this is temporary certificate, level 3. Level 4, it is digging deeper. Here you can say that this is used for supervisors. And it has 2 years to be valid for, same as level 3. IWCF level 4 certification, 5 days, 2 years. Candidates can select surface only or surface and subsurface. 2. If you want to work onshore only, not in the sea, you choose surface only. If you want to work both, you have to use combine surface and subsea stack, BOP stack. Level 4 has certificate of 2 years assessment exam. Practical assessment also, there is simulator exam. I told you, as if you are sitting in the rig and you have to kill the whale. What do you do? What is the type of calculation that you have to do? So it is either face-to-face or this level, which one? Procedures and principles plus equipment, it is either online or face-to-face. While this one, the simulator, it has to be face-to-face, mandatory, because you have to do this one under the responsibility of your assessor. So if there is no assessor, how can you do it? Level 4 exam, this is the time also for subsea. Here is the exam, example of the certificate, level 4. IWCF well intervention, it is very similar to the drilling, but the syllabus is different. Program objectives, you have it here. It talks about the completion, and this program is for people who are in critical well control positions during well intervention operations. Candidates will complete an accredited training course, tough according to IWCF syllabus. We have syllabus for well intervention, so you have to study it and you can see. If you want, I can send you the syllabus. If Mr. Athir remind me at the end, I have it, the syllabus, and you can go through one by one these items to see yourself that you are very familiar with it, to prepare for their assessment. So you have to have your syllabus. I will provide you. Different levels of training are available, same as that, level 1, level 2, level 3, level 4. So it is clear, level 2, 5 years, level 3 and 4, 2 years. Here, program structure, what do we study? What is the syllabus? 3 different levels. Each level has its own syllabus. So if you want, I can provide you, and you can study training available, the different roles within the industry. Level 2, you can study drilling and well with personnel basic training. Level 3 also, level 4, and so on. So it is very clear. You can study and see. The standard of certification in this program is based on the pressure control knowledge required to work as service equipment operators and supervisor personnel. So you have to work safely. You have to know all the subjects that are included in this syllabus. It is not very difficult, but you have to study to see them. If you have to go and visit any wireline or coil tubing or completion or work over rig, all of them, you can see them and check one by one. You have to cover all the subjects of the syllabus. Then you can be assessed, do a course of 5 days, then do the assessment. This assessment is done by under supervision of Aberdeen in Scotland. So if you you pass 70%, then you can have the certificate. In the beginning, temporary certificate, and then within 3 months, you have to get permanent certificate, which is valid for 2 years. Here you can study these. We talked about them. We have barrier principles, well information, shutting procedures, pressure control methods, problems, pressure control management. All of these, I deliver them in the IWCF courses. So we spent, last course, I spent 28 hours, and I am talking like this, 28 hours within 4 days. So it is not easy. I am talking and you are listening, you are watching, but at the end, you have to study them and do exam to pass. If you don't pass, it will not be good for you. But as you are preparing yourself early, you will pass it very easily. Candidates must attend both compulsory, this is mandatory, compulsory components, and you can choose one or more optional components, which is wireline or coil tubing, snubbing, in a combined certificate program. They write for you wireline and coil tubing. You are certified. If you have snubbing, they write it for you, snubbing, and so on. Now, content includes equipment, completion, wireline, coil tubing, and snubbing. Principles and procedures, same as this, repeated. Let's move on to the well life cycle. We took it in the last lecture. I think if you remember it, well life cycle, we start with well construction, which is drilling and completion. Here you have to have what? The IWCF or IDC for drilling. In the maintenance, workover, and well intervention, here you have to have well intervention, IWCF or IADC. Here, production, there is no intervention from our side, and or in the plug and abandonment, the well is closed. Here, we have the well control calculations. These calculations and laws should be memorized in your brain, very strictly. So there is no compromising. Hydrostatic pressure equals TVD, true vertical depth, times density times constant. So this, you have to memorize it as if your name. Don't tell me that I forgot that one question can make you pass, and one question can make you fail. Here, if you take the true vertical depth in food and density in ppg and use this constant, while if you take the true vertical depth in food, density in pound per cubic foot, then you have to divide this by 144. When you want to calculate the hydrostatic pressure for a column of oil and gas, you have to calculate the hydrostatic pressure for oil and add it to the hydrostatic pressure of gas. Hydrostatic pressure of gas, you have to calculate it. You have closed-in tubing head pressure times correction factor. So he has to give you how much is the gas oil contact, for example, 2000 or 3000, and specific gravity of gas. Then there is table, it can give you the correction factor. Correction factor, for example, 1.11 times, for example, closed-in tubing head pressure 2000. It will increase a little bit, maybe 100 psi or 200 or plus minus. So it gives you the pressure correctly and accurately. Bottom hole pressure also, what is bottom hole pressure? It is hydrostatic pressure plus closed-in tubing head pressure. In this case, bottom hole pressure, it will be equal to reservoir pressure. You see the reservoir pressure? It equals bottom hole pressure. Bottom hole pressure or reservoir pressure, it equals hydrostatic pressure in the cone of the well plus closed-in tubing head pressure. So these laws should be as if your name. Don't forget them, please. I think you take them in the university, although you have to memorize them here. Because they are very important for your knowledge and to make you pass the exam very easily. I can later on give you some calculations and some problems that you can practice by yourself. You sit down, use your calculator, calculate this pressure, this density, this API, and so on. Specific gravity equals 141.5 divided by 131.5 plus API. So API, which is the density that was introduced by American Petroleum Institute for water, it is 10. So if you add this to this, it will be 141.5 divided by 141.5. So the specific gravity of fresh water will be 1. So this info plus this info plus this info, your mind will be full of useful information. The learning is cumulative. So you cannot take everything in one day, but you can build yourself. Specific gravity, it is oil density divided by water density. Pressure gradient, we have either, if you have the density of the fluid in ppg times constant 0.052, or if you have the specific gravity of the liquid, then multiply by 0.433. Then we can move to time required to pump in minute. If you want to calculate it in the tubing or in the annulus. If in the tubing, you have to have the tubing capacity, which is in barrel per foot, times measured depth, the length of the tubing in measured depth, not the true vertical depth. You see, I want you to focus on this, please. You see here, hydrostatic pressure, we calculated it based on true vertical depth. You know what's the difference between true vertical depth and measured depth? So when we drill the well, it will be like this. Look at me, please. Like this. It is not vertical like this, vertical 90 degrees. It will be like this. So the deviation may be 10 degree or plus minus. So this depth is vertical. We take it as a true vertical depth for pressure, because the pressure is considering the gravity. The gravity will be vertical, right or wrong? Gravity is acting as vertical force, not like this. This is used, measured depth, we call it, for calculating the volumes. I think it is clear for you. Here, we calculate the tubing capacity in barrel per foot times measured depth, as I told you, which is this one, divided by pump rate in barrel per minute. We'll obtain the time to pump, which is minute. Now, it may be not clear for you, but if I give you a question, including calculation, and you will sit down and think about it and use these laws, it will be very easy for you. Time by time, it will be easier, and you will find the solution very easily. In annulus capacity times measured depth divided by pump rate in barrel per minute. Here, for the completion, for the type of the wells, we have exploration or production. Exploration, when we start drilling in an area for the first time, we call it exploration. Production, we have drilled before, but we want to improve this field, so we call it the production well. We have also vertical, deviated, and then this horizontal. So 90 degrees, it is horizontal. We have all well types as per the production phase. What do we have? We have oil producer, gas producer, water injector, gas injector. We have WAG. Sometimes we inject water, then stop and inject gas. Then inject water, then inject gas. We call it WAG, water alternative gas injector. Then we have water supply well. We have water disposal well. So these wells, I think you have to memorize them also, because you have to use them in your future. Here, the completion, we come to the completion. After completing of a well drilling, the well should be completed to enable it to produce. So you don't have to compose your casing in the well to the well production fluids, corrosive fluids, pressure, temperature, CO2, H2S, etc., etc. So you have to protect it because it will stay in the well for the well life. While if you have damaged completion, we are talking about completion. If you have damaged completion, then you can move work over to the well, kill the well, pull the completion, and run a new completion and finish. This is the whole problem. But if your casing in the well has damage, then what shall you do? You have to shut in the well or start fixing this problem, cut the casing, cement it, perforate it, then squeeze cement, and so on. And it is a costly operation. And there is deferment in the production. There is deferment also in the injection if it is water injector. So you have to keep your casing in a safe condition. Completion design criteria, you have to have a profitability. If you expect to produce from the well 10,000 barrels per day of oil, then you have to run the suitable size of completion. So if you run 3.5 inch, it will have the maximum production rate, say 5,000 barrel per day oil. But in this case, you don't have the profitability. You have to increase it to 4.5 or 5 inch tubing. In this case, you achieve your target. I know in Kirkuk, in Iraq, some wells are producing each well 20,000 barrel oil per day. So it is producing from 7-inch casing without tubing, or 9 and 5/8 inch casing full, and it is shallow, about 1,000 meters from the surface. So this is different from well to well, from field to field, and we have to understand this. This is called here the completion design course. We have how can we design the completion? What are the criteria that control this choosing and designing of the completion? Here it should be flexible also for handling the current and the future problems. So if we expect that after 5 years we have to operate gas lift system, in this case we can run side pocket mandrel and keep it shut in. We keep a dummy valve in the side pocket mandrel and keep it in place without using, because after a year or 10 years or 5 years, instead of retrieving the completion and running new completion, it is ready. Just pull the dummy valve and run gas lift valve. That's it. Simplicity to allow the most efficient installations and maintenance activities. So if you need F nipple, you run F nipple 1 or 2 or 3 or 4. If you want R nipple, you run. If you want SSD, if you want subsurface safety, all of these should be there in the completion. Here also we can find the completion objectives. Why do we run completion objectives? I told you we have to protect the casing, that it should stay for the whole life of the well, to provide optimum flow condition. We want to produce from the reservoir to the surface, but you have to have a conduit. This conduit is called completion. Downhole emergency isolation. If you have any problem downhole, you have to isolate it. You can set wireline plug and isolate it. It permits downhole chemical injection. You can run also control line to a certain depth and pump chemical injection, so you can protect your completion and your well. Permit downhole measurements. If you want to do pressure and temperature survey, then you can run downhole gauge. Isolate producing zones. Sometimes you have 3 zones. How can you produce from one and close the other one or other 2? This case, we have selective completion. We run 2 packers or 3 packers or 1 packer. So we can control our production as per our strategy and how we plan to produce from this way. Allow selective production. We mentioned it. If you have 1 zone or 2 zones or 3 zones or 4 or like this, you have to have a plan how to produce from it. You see it here. This is a type. It is open hole here, well completion. Here we have cased hole and perforated. Here we have dual. You see cased perforated completion, open hole completion, and here multiple zone completion. You see this zone and this zone. The upper zone is produced from the short string. Long string is producing the lower zone. And this is dual packer. Here we have a sliding side door. If we open this one, then we can produce from this SSD to surface. If we want to isolate this zone, we set a plug here. You see it? If we want to produce from the short string, we produce from this upper zone. So it is like an art. It is very interesting. The completion design is very interesting, and you can have too many funny things and useful, and it is a science. Now we have completion types for natural flowing injection wells. We have single completion. We'll see them now. You have single selective completion, dual completion, and dual selective completion. These are the types. We have single vertical completion. This one, you see it, single vertical completion. We have single selective vertical. As I told you, you have 3 zones. You can produce from this one, or from this one, or this one, or from all of them. You see, this is chemical. It is pumping control line from surface to here. To protect your completion, you pump corrosion inhibitor here through the control line, 1/4 inch. In this case, if you pump corrosion inhibitor, you will protect your completion, you will protect your flow line. Here we have dual vertical also. We inject here in the upper zone. You see it, inject water, and the lower zone we inject gas. Here, single hole stem, we don't have F nipple, R nipple completion restrictions, we don't have it. Even you see there is there is subsurface safety guard here. You see it, this one, this is control line. This is mandatory for safety reason. Clear for you? I think clear. Here we have 2 types of well, horizontal and vertical. You see, this is vertical well, and this is horizontal. This is typical permanent completion and the accessories that are there in the completion. This one also, you can start from bottom till up. You see it, from bottom till up, from wireline entry guide till wellhead, one by one. Here we have the barrier principle. What is barrier? Barrier, any component or substance that prevents the flow of wellbore wellbore fluids unintentionally to the environment or to another formation. So we put barrier. You see this bit? This bit is very dangerous. Imagine that this baby is walking to here. This is it is the hydrocarbons. So, and this is the surface. So how can we prevent it from this hydrocarbon to go to the surface, to here? We have to put barrier. This barrier, either completion, packer, wellhead, subsurface safety valve, tubing hanger, tubing head spool, all of these, we consider them as a barrier. So watch this video. It is the barrier definition here.
Our cities, I've seen all of the time spent. Hope you know that it's not always that hard. Head, side, don't know.
Very clever dog.
Perfect road to go down, but I know
It is safe. I will repeat it for you another time. It's dangerous.
all of the time to spend. Hope you know that it's not always that hard. And side, dark room, the perfect road to go down, but I know.
Very clever dog. Here we can see well control and barrier definition. Well barrier, as I told you just now, is defined as a component part of well designed to prevent fluids or gases from flowing unintentionally from a formation into another formation or to surface. This is very easy. If you memorize it, you will use it for your future certificate and assessment. Barrier theory, definition of a barrier, any device, a fluid or substance that can hold well-bore pressure, either tubing or tubing hanger or packer or whatever. The aim and importance of using barrier to contain well barrier and work safely on the well. If you don't have barrier, you will not be able to work safely on the well. So you have to take this barrier. Barrier types. We have two types of barrier, a fluid barrier and mechanical barrier. During drilling operation, a minimum of 2 tested and verified barriers should be used. This is dead well. While in the well intervention, we work on the live well. We have to use a minimum of 3 tested and verified barriers. So this is the IWCF rule. If you use 2, it is not required. Even if you have low pressure, if you have 150 psi wellhead pressure, he asks you, can you work? You tell him no. You have 3 in well control. Hydrostatic barrier, you go through all of these, how to calculate the hydrostatic pressure and so on. Mechanical barrier, also any substance that can be set in the flow path and prevent the flow of wellbore fluids unintentionally. So if you set the plug, wireline plug, it will plug the well and will not allow it to produce to the surface or to another reservoir. Properties of mechanical barrier, you have many properties, should be tested from direction of flow. Barrier is tested after setting. Barrier cannot be tested from the if it is not tested from the direction of flow, then we can do inflow test from our. Also, if it's a pressure rating also should be suitable for well condition. If it is high H2S rating or not. If we have high H2S in the well, then the equipment should be high H2S rating also. If it is not holding pressure, what shall we do? We have to retrieve it. For example, wireline plug. We have to retrieve it, redress it, and set it again. Or we have to set the backup plug above it. If you have the F nipple at this depth, above it, F nipple 100 feet, you set it. If you want to set another one, it will be 2 barriers but tested. Classification of barriers, we have a primary barrier and secondary barrier. A primary barrier is the first line of defense and can hold well pressure. It should be leak tight. There is no leak, 0 leak. Secondary barrier, the second line of defense, in case of a primary barrier fails, it can be used. So if the primary barrier has failed, then you can go to the secondary barrier. Then you can fix the primary barrier and return it to the normal. In well intervention, the primary barrier in wireline operation, what is it? You have stuffing box or chemical injection head for wireline. The secondary barrier is the BOP. Tertiary barrier will be the upper master valve. While in the drilling or workover, the primary barrier is the drilling fluid. Secondary barrier is the BOP. You have to understand this and memorize it, please. So we use this one, quad BOP for coil tubing. This is for wireline, dual BOP. Stuffing box for these are examples of barrier. Stuffing box for wireline, chemical injection head. This one for wireline, either electric line or braided line. And here we have a stripper. This is for coil tubing, also quad BOP. This one, hydraulic quad. Here we have lubricator, you see it, and here stripper. A primary barrier. Here we have lubricator, and quad BOP is the secondary barrier. While this and this is what primary barrier. This is secondary barrier. This is secondary. This is secondary barrier. Tertiary barrier will be the shear seal BOP. Here we call it well barrier envelope. What is well barrier envelope? More than combination of more than one barrier. You see it here. We have during drilling, we have drilling fluid. We have the casing. Here we have casing of previous stage. You see here. This is during production. You have subsurface safety valve, packer, and completion. The blue one. Here during intervention, what will be during intervention? Here also, this is the secondary barrier envelope, the red one. Here, plug and abandonment. So each stage of well life cycle, it has its own barrier envelope. Here is the tubing hanger. We set it at the top. It can hold the completion tubing and isolate between tubing and annulus. Here we set the back pressure valve. Here is two-way check valve to isolate the above the tubing hanger from below, or to test the Christmas tree. Here subsurface safety valve. We have two types, tubing retrievable and wireline retrievable. It can close in case of an emergency. You see wireline retrievable, it can be retrieved and set by wireline and tubing retrievable. And we can run control line from surface to it. It is located almost between 150 feet to 400 feet. So it depends on different properties. This is the subsurface safety valve, and here is the flapper. You see the flapper, this one. If it is closed, then the well will be closed. If it is open, you see flapper is open here. You see this one, flapper is open. Then the safety valve is open. Flapper, this one is closed. Then the safety valve is closed. This is closed. You see it? We call it downhole safety valve, self-control subsurface safety valve, self-safety valve, tubing retrieval. So different names for the same item. But the most known name for it, we call it surface control subsurface safety valve. This one, surface control subsurface safety valve. Here we can come to the production string. It is a tubing. It has different sizes, either 3.5 inch or 4.5, 2.78, 2.38, maybe 5 inch. We can consider above it will be casing. Below it, it is the tubing, production tubing. And there are also couplings. You see these couplings. This we call it J55, this type. This red one, we call it C75. So you can connect this piece of tubing from above and below using the coupling. We call it coupling. If the pressure inside the tubing is increasing, it will explode. You see, burst. This is burst. Because the pressure from inside to the outside is higher than required. While if the pressure from outside to the inside is higher, it will collapse. Here, production packer. What is a production packer? It isolates the tubing from the casing, and will make the production packer in safe situation. In this case, we put inhibited water in the annuals and we can make this annuals safe during the whole well life cycle. Based on their primary use packers, we have either two types: permanent packer or retrievable packer. Permanent packer is used for high pressure wells and used for long-term running. So if you want to keep the packer in the well and completion for 20 years or 30 years, you have to run permanent packer. But when we want to retrieve it, you have to use milling for it. So it will be retrieved by milling. While for the retrievable packer, it can be pulled by the completion. Here we have different parts for the packer. You have slips here. We have packing element. And here there is mandrel. You see, this is packer. This is dual packer. This is short string, this is long string. Here we have this DST, we call it. DST we run packer, upper packer and lower packer, and we produce the well from here just to test it. You see it? Landing nipples, we can set flow control devices such as wireline plug or other tools to isolate the packer, the zone or the completion. Or we can set packer hydraulically by setting plug below the packer and increase the pressure in the tubing. In this case, the packer will be set in place. We have three types of this, we call it landing nipples. We have no-go nipples. We run it one piece, only one nipple at the last bottom of the completion. Then we have selective landing nipples. For example, 2.75 inch F nipple, then 2.75 inch F nipple, 2.75 F. So three nipples have the same size, and we run them in different depths in the completion. We have also the third type. We have a ported or safety valve landing nipple. In case of tubing retrieval, subsurface safety valve has failed, and don't want to replace it because you don't have workover for the time being, what shall you do? You have to lock open this tubing retrievable safety valve using lock open and the lock open tool. After that, it will stay open. Then you can run the wireline retrievable subsurface safety valve inside the tubing retrievable subsurface safety valve, and you set it in the this one, ported or safety valve landing nipple. In this case, you can flow the well or inject the well as normal till the workover comes to the well and retrieve the subsurface safety valve. Here, no-go landing nipple. It has no-go at the bottom. Selective nipple, it doesn't have no-go. No-go can be found in the plug itself. Here, safety valve landing nipple. We set wireline retrievable subsurface safety valve inside it. Circulation devices, we have two types of circulation devices, sliding side door and side pocket mandrel. This is side pocket mandrel. We set the gas lift valve inside it, or chemical injection valve, or dump kill valve, or dummy valve, different types. For sliding side door, we open it and close either for circulation or for selective production or injection. We will see them. You see, this is SSD. Look at it. This has holes in the fixed part. You see it? In the inner part, we have a sleeve. This sleeve has holes. This is closed. Why? Because the holes in the movable part of the SSD are not opposite to the holes in the fixed part. You see them? Different. So there will be no circulation through this part. While here it is open. Why? Because the holes of the sleeve are opposite to the holes in the fixed part of the SSD. So there will be circulation. Here is the SSD, this one. We have another one. It is called side pocket mandrel. This side pocket mandrel, we run it with the completion and make circulation or make injection, gas injection. If you inject gas from annulus to the tubing, it will push fluids, oil, and gas, maybe water also, from the tubing till surface here. So we can run 1 or 2 or 3 or 4 side pocket mandrel and run gas lift valves. So this is called gas lift system, and we run and pull these valves using kickover tool. This is called kickover tool, and this valve is inside the side pocket mandrel. We have flow couplings and a blast joint also. You can be asked also in the exam for them. Flow coupling, it is used to reduce the erosion and is used upstream or downstream of the completion components such as F nipple, R nipple, SSD, subsurface safety valve, and it has bigger wall thickness than tubing. It has less ID of the tubing, while from the outside it has same as tubing OD. For blast joint, it is used to reduce the erosion due to sand, due to fluids from the reservoir to the completion. So its OD will be, you see it, this one. Its OD, this one, is bigger than the tubing OD. While the ID, it is same. Here the flow coupling, the opposite. We have the OD is same as OD of the tubing, while the ID is more. You see, this is flow coupling. Landing nipple here, above it and below it. This erosion is resulting from the turbulent flow. We have two types of flow, turbulent and laminar. Laminar, there is no problem, like this. While turbulent, it will be like this. So this will cause erosion to the completion components. We can reduce this erosion by installing flow coupling upstream, and this is upstream and this is downstream of the completion components, such as flow landing nipple. You see, this is the flow coupling. Polished bore receptacle, we have this one, polished bore receptacle. We run the packer here, this is the packer, and above it we run the tubing for completion. Tubing and completion, by time, it is heated up or contracting due to the temperature of the fluid in the well. In this case, what will happen? The tubing will contract and subtract. So contract, the volume will be less, and expand. This expand will make the length of the completion more. So how can we control that? Using this polished bore receptacle or expansion joint. This one. It is moving, and here we have seals. You see the seals here. Wireline entry guide. When we run the completion tool string, wireline tool string, or coil tubing outside of the completion, then we have to run it again to the completion. If we don't have a suitable tool here, such as wireline entry guide, then the wireline will cut or the coil tubing will get stuck. So we have two types, bell guide, and here we call it the mule shoe. So everyone has its own function. Gas lift system, we explained about it. You see here is the side pocket mandrel, side pocket mandrel, side pocket mandrel. We set inside it the gas lift valve, gas lift valve, gas lift valve, and here inject gas from the annulus and push the fluids to surface. When there is no fluid is pushed here, this valve will close and the gas will go to the second gas lift valve, side pocket mandrel, and lift it. If there is no fluid, then it will close and go, and so on. This is the principle of gas lift system. If you understand like this, it will be fantastic. You see gas injection to here, and it will shift it up, push it up. Yeah, and here is the pressure. There is drawdown from reservoir to the bottom hole. This is called inflow. So if anybody asks you what is the inflow, you tell him it is the flow of reservoir fluids from reservoir to the wellbore. What is about outflow? Outflow is the flow of wellbore fluids from the bottom hole to the surface. So this is the principle. Here we have dummy valve. If we want to keep the side pocket mandrel closed, we run dummy valve. If we want to produce using the gas, you run gas lift valve. And here is the side pocket mandrel. We set it here. we have seals. You see the seals up and down, and between them we inject gas and we produce what is in the tubing. Well kill methods. We will come to the end of our lecture. If you want to kill the well, we have 4 types of killing method. Reverse circulation, forward circulation, bullhead, and bleed and lubricate. Reverse circulation, we pump down the tubing. I will show you. You see, we pump from here, reverse circulation, from annulus till here, till we have SSD here, till the tubing, then up. If we want to kill the well using forward circulation, we pump from tubing down to the circulation device, SSD or side pocket mandrel, till surface here, up annulus till surface. The other third one is bullheading. If we don't have circulation device, we have to bullhead from tubing to formation to here. If the formation doesn't take a pressure and the well has gas, we cannot bullhead. So what is the other killing method? It is bleed and lubricate. So if you have gas like this, but it has a 3000 psi, so and you cannot bullhead, there is no injectivity into the reservoir. What can you do? You bullhead 5 barrels of kill fluid and wait. After waiting, what will happen? This brine or kill fluid will go down. It will go down to here. What will go up? The gas. Then we bleed off the gas. If we bleed off the gas, then what will happen? We will repeat the same. We bullhead 5 barrels of kill fluid or brine. Then we bleed off the gas, and so on, till we reduce the pressure in the tubing. I will show you the kill graph. We call this one is kilogram. Here the initial pressure when we started killing the well, you see it, 2367, and here when we this is reverse circulation. When we pump the kill fluid from the annulus, and here it became 0, the tubing head pressure. After pumping 284 barrels of kill fluid. Then here we see that annulus pressure is increasing, then it will drop. So the tubing and casing volume, the annulus and tubing volume will be the total well volume, which is 1,200 bar. You see it? Here we have gas in the beginning. All of gas got out. You see? Then this oil is getting out also. Then you see kill fluid in the blue color. It will be pushing the completion fluid here. The brown color is called completion fluid. So we push it here with kill fluid. After that, kill fluid is going down, and oil and gas got out. You see it? Where is oil and gas? This is gas and this is oil. Here we got them out both. Here we continue pumping kill fluid in circulation device. After that, we see that the tubing is full with completion fluid, and the annuals is full with kill fluid. Here in the last stage, we see that the well is full with kill fluid in the tubing and the annuals. And here is the kilogram. We call it kilogram. Here, in this case, we pump this fluid is less, has density less than the completion fluid. While in this case, we have kill fluid has higher density than the completion fluid. So if completion fluid is 10 ppg, we use 11 ppg to kill the well. So, and this is the kilogram. Here where gas is out, here oil is out, and here we keep overbalance. What is the overbalance? This one. You see it, 202 psi, 202, 202. We keep pressure at surface to keep this well overbalanced. Otherwise, if we circulate from here to here, we will keep the fluid, well fluids flow. We motivate the formation to flow through this tubing from the reservoir up to the surface. So we keep overbalance. Here, overbalance is 202 psi. This kilograph for bleed and this is bullheading. This is bullheading. So we have to keep bullheading between these two lines. This is for maximum initial. Here we have a frag. Above it we can get a frag, and here we can not go below it because the operation will not be as per procedure. Here the last one will be for bleed and lubricate. As I told you, we pump 5 barrel, increase it, then the bleed of the gas. Pump 5 barrel, bleed of the gas. Pump and bleed. And at the end, we started with 1000, it will end with 550 psi. You see, we pumped 120 barrel. It is the tubing volume. So if we keep pumping in the second day, we will get maybe very close to 400 or 300. So it is okay. Hydrates. What are hydrates? It is a crystalline solid compositions formed at the top part of the completion, in the safety valve, in the hanger, in the completion, in the choke valve, Christmas tree valves, flow line, all of these. So it can form if you have 4 conditions: high pressure, low temperature, presence of free water, and presence of gas. So if you remove one of them, this hydrate will disappear. So how can you make it disappear? By different ways. You can pump methanol or glycol to prevent it. If you have already formed hydrates, what can you do? You have to pump in the surface lines, for example. You have to check where is it, where ice is formed in the outside of the flow line. In this case, you can expect that here you can find hydrates. So you can pump hot water or you can increase the temperature of this part. After that, this hydrate will disappear. Also, the pressure, if you drop it, we mentioned increase the temperature. Gas, you cannot eliminate it. Every well should have gas. Water, if you use a mixture of methanol and glycol with water with 50-50, 50% methanol and 50% water, in this case, what will happen? We will prevent forming of hydrates. So each time, 4 or 5 questions from hydrates come in the exam. So if you understand the principle, you will pass 5 questions. 5 questions means about 10% of the exam, and almost same questions and answers are repeated. I will give you some of them. So this hydrate curve, above it hydrate region, below it non-hydrate region. You see the relationship between temperature and pressure. So above it we have hydrate region, below it no hydrate region. So we try to keep ourselves here. We talked about it. Hydrates, we can read them quickly. The 4 things required for formation to form are gas, free water, high pressure, and low temperature. Injecting brine into the low flow steam can reduce the formation of hydrates. Then hydrates may cause damage if they become free with a high differential pressure, as if bullet. You can see that. They can penetrate the flow line or damage the surface equipment. Hydrates only form if there is free water present. Hydrates are less likely to form if injecting glycol. Glycol and methanol, if you use them, less likely to form. Hydrates are common downstream of chokes. All of these are the questions that come in the exam. So if you at least you memorize this and the next slide, you will take 10% of the exam. I am guaranteed. So only 2 slides, I give you the summary of it. Hydrates are common downstream of chokes, pressure relief valves, and blow down drums. The following measures can be used to remove hydrates. Also, this question is repeated in the exam. Every exam, you can see it. Check for the presence of external ice. I told you that in order to locate the hydrates. Inject methanol. Try to warm up the hydrates using a high pressure steamer or hot water, you call it. You see, this is the hydrate. Well intervention, we have slick line, we have wire line and coil tubing. Wire line includes slick line, braided line, and electric line. You see, this is called slick line. This is braided line. If there is problem with the slick line, we use braided line. Braided line also is used in swabbing. If you want to produce the well by swabbing, you can use it. And electric line for logging, for perforating, for water shutoff. So you have a multi-conductor in the center. You can send electrical signal, while here you cannot. Here are the slick line. We have 2 string, standard 2 string. About it, we have rope socket, stem bar, mechanical jar, knuckle joint, and wire line running or pulling tool. You see, these are different types. So if you have wireline workshop besides to you, if you ask your teacher or doctor, please let us go and have a look at them. You will see all of these. Look at them. You can fix the video and take a photo for them and memorize them. You see all of them. This is in the workshop. A braided line to fish the slick line or for swabbing. The size used is normally 3/16 inch. While that one, slick line, we use it 0.108 or 0.125 inch. It is very thin, this one. It is very thin slick line. While this one is 3/16 inch, and this is the 3/16 inch electric line. And it has conductor, multi-conductor, or a monoconductor inside it. These are wireline tools. Here, E-line, we use it for logging, for perforation, and for water shutoff. You see, this is the pressure control equipment. This is for slick line, and this is for electric line. We have stuffing box here. We have tool catcher, chemical injection sub, lubricator, bleed off valve, and so on. Here, BOP. Here we have chemical injection head. You see it? Chemical injection head, electric line. Coil tubing. Here, this is the most important invention in the oil and gas industry regarding well intervention. It is a tube, a small tube, is run in the well, metal tube, run in the well. You can pump fluids inside it, you can pump gas, you can pump whatever, or you can do milling, fishing, perforating, too many things you can do, too many operations. So you can do it and you can save the workover cost and the deferment of the oil production. In this case, you save money, you save the production of the well, you have safety, too many things with this coil tubing. It is not very expensive in related to the workover, but it has a very high efficiency. It is quick, it is simple if compared to the workover or drilling rig. What operations can we do using coil tubing? You can do logging, cementing, nitrogen kickoff, coil tubing convent perforation, open and close SSD in horizontal completion, stimulation and fracking, scale and sand clean out, milling, fishing, etc. So this is the coil tubing package. You see it. We have control panel, reel unit, power pack, injector head, BOP. These two ways near each other, maybe lateral, maybe here. Here we have nitrogen unit. This is nitrogen tank. The capacity is 2,000 US gallon. It comes in liquid condition. We evaporate it. We move it from liquid to gas at a temperature of minus 195.79 degrees centigrade, almost 195 minus 195.8 degrees centigrade. And here we have the nitrogen unit, we have the evaporizer, we have exchanger. Temperature can increase the liquid nitrogen and move it to gas nitrogen. Heat exchanger here. And here we have pumping unit. We have the cabin of the operator, valves, lines, and here displacement tank, 2 tanks, 10 barrel by 10 barrel. A rig up also for the coil tubing, you see it. Open and close SSD. If you have a horizontal well, you are mandatory required to run the shifting tool on the coil tube, because the wire line goes down under the effect of gravity. But if it is like this, then like this, how can you send it? You cannot. You have to use coil tube. You see this one. This is horizontal rail. You run it here, then wire line will stop here. How can you go there? Using coil tube. Stimulation, when we want to increase the productivity of the well, if we have here damage in the formation, you see it in the nearby of the formation, we pump acid. If it is acid soluble, bullhead it, inject, then allow it to flow back of spent acid, then the well will produce by itself. So it is a means of reservoir productivity increasing or stimulating. Here also, before during acidizing, we pump acid, and here after acidizing. You see that more channels are delivering oil and gas from the reservoir to the well. And here differential pressure or drawdown, we call it, from reservoir pressure till bottom hole pressure. Say the difference is 50 psi, so delta P is 50, and we can see how much we are producing at this depth, this pressure differential. Frac, if we increase the pressure above the frac pressure, the rock will frac, and more holes will be formed inside the rock. You see, after that we pump propant. We call it a propant or artificial sand, and keep this shell, keep it open, and allow the reservoir fluids to go from the reservoir to the downhole. You see it like this, flow from the reservoir to the downhole. This is a frac operation. You see how much is the cost, how much is complex. Here is the way. Examples, this is the last 4 slides. We will finish. I will give you examples of the question. For first subject, we have completion operation exam. I have 4 questions, or 4 questions, yes. I will tell you how the questions come in the exam. A completion is run open, down is run open-ended, and with the perforations open. What is the primary barrier? The drilling BOP, the wellhead, the cementing casing shoe, or the fluid column overbalance? I told you, when we use the fluid, it should be primary barrier. So if he tells you, what is the primary barrier? When you see fluid, straight away you choose fluid column overbalance. Question number 2, on a well with 150 psi surface pressure, only one barrier can be proven prior to rigging up. One barrier only. For what? For operation here. Can you work? Yes or no? No. We have to have 2 tested barriers here, right? 3 in workover, in the drilling and workover, you have to have 2 tested barriers, and well intervention 3 tested barriers. So the answer, the work cannot continue using only a single barrier. So with the drilling, minimum 2 barriers, with well intervention, minimum 3 barriers. the last two questions from completion operation. The term positive plug, what does it mean? To describe a particular type of a plug. What does this mean? So we say it prevents flow from either direction. Question number 4, typically, how often are permanent barriers to be tested? Select two answers. We select after installation and when a leak is suspected. Now we move on to we move on to completion equipment. We have this question. How does a production packer create the annulus, a tubing seal? By sealing against the tubing and casing walls, isolating the upper annulus from the lower annulus, or some. Second question, which of the following is true about a production retrievable packer? Two answers. What we choose can be either set mechanically or by application of hydraulic pressure, mechanically or hydraulically. Number 2 can only be retrieved when the completion string is pulled out of the hole. I mentioned that when I explained. The third question, which type of closure mechanism can be fitted to surface control wireline retrievable downhole safety valves? We have the flapper and both. He needs two answers. We have here coil tubing and wireline. We'll finish. 2 slides. Coil tubing exam when in side door stripper, if wellhead pressure increases, does it assist the assembly to increase, to retract? No. There is no relationship between side door stripper and wellhead pressure. Question number 2. Which factors influence the long-term structural integrity of the coil tubing? Two answers. We have continuous cycling of the coil tubing and gooseneck radius. 2. Last question, why the shear seal VOP installed just above the Christmas tree? Select one answer. To allow the coil tubing to drop below the Christmas tree valves after cutting. So if we cut it, it will drop below the Christmas tree and will fall down. The last sheet in our lecture for today is questions for wireline. Which one of the following is correct run configuration from top to bottom for braided line work? It is braided normal from top to bottom, right? A braided line normal, then braided inverted, then shear seal. Question number 2. After closing the wireline BOP, which of the following actions are mandatory before breaking out the lubricator above the closed wireline BOP? We have 3 answers. We have to inflow test after closing the BOP, inflow test the wireline BOP. Second, screw on the manual stems to lock the hydraulic rams, because if the hydraulic system has failed, then there will be no barrier to keep it closed. The last one is bleed off well pressure above the closed wire line, bleed of the pressure above the closed wire line BOP. So Close the BOP. Bleed of the close it hydraulically, then manually. Then bleed of the pressure above BOP, then inflow test the pressure above the BOP. So these three answers that we have to know. Here we finish. I will go to the
Many thanks about this interesting and valuable information, Mr. Samer. You already summarized this information about international well control information. Many thanks, Mr. Samer.
thank you very much.
And let's now we go to the question. If anyone like to ask a question, he can raise hand and we will unmute him. And another hand, you can write your question on the box chat on the Zoom.
Yes, please.
The first one, Mr. Mohammed Bahrain, you can open your microphone.
Assalamu alaikum.
Welcome, salam.
Shall I speak in English or Arabic? What's better?
English, because it is English, so we should stick to it.
Okay, sir. By the way, thank you so much about your summarize. It's good information, and we interest with you. But I have a question about international control well form.
Yes.
You said we have we have 4 stages, first and second and third and fourth.
Yes.
By the way, could you please explain it very easy? And I need to know what's the difference between them, because you know the problem for internet in Yemen is so about the connection. I don't get it.
Yes. You have four levels of the.
Okay.
You have 4 levels. Thank you for your question, Mr. Muhammad. We have 4 levels of knowledge. Level 1, we have we call it level 1, level 2, level 3, level 4. So as you dig deeper, you have to be more responsible during your operation. So this one is called awareness. So you are in the level of awareness now. You can go into the website of IWCF there, or if you want, I can send you the syllabus of IWCF and you can study it by yourself. Then there are modules. You can watch them for 2 or 3 hours. After you finish each chapter, you have to answer questions. 5 questions each chapter. You have 7 chapters. After that, you will take the certificate. This will enable you to increase your knowledge. But without this lecture, you cannot start with it. So this is lecture will help you to start with this way. This way is long and it is not easy. So you cannot start by yourself. You need some assistance, some help. I am helping you now, and you will study and you will work on yourself to get higher and higher. So if you are a supervisor, either wireline or co-tubing or rigless, all of them, you have to be level 4. So you have to be, you have to attend level 4 course 5 days, full 5 days. The last day is exam. But for your level, you are at the university now. For this step, you are not allowed to go to level 2 or 3 or 4. Level 1 for you, I want all of you to attend this course and make sure that you have achieved some progress, because the science is cumulative. You cannot learn everything in one day. So you visit the site that I told you. It is online only. because it is a free of charge. So you cannot go to everywhere and pay extra money for nothing. Okay.
Okay, thank you, sir. About this, okay, I get it. Could you please share this lecture and the syllabus for ICWF?
Sure, sure. I will
Yeah.
send it to you. But I need a promise from you and others. You have to study them.
Yeah, I promise you, I need to improve myself. That's why I needed to ask you and to share it for all of us.
Otherwise, I will not send anything to you.
Yeah, sure, sir. You are the supervisor and other assistant for everyone, and to help him to improve more and more, to get more knowledge, more information, to understand.
Yes.
This is interesting, and to get more knowledge and to get a good job and a good position. That's why we need to improve ourselves.
Really, I am very happy to hear that from you, because these two universities seem that students are very tough, very hard workers. So
Yeah.
this enforces me to join you always and keep providing you with useful and interesting subjects.
Yeah, sure, sir. We need to improve ourselves. Because, sir, right now I have a chance in my university. I'm undergraduated from my college, Oil and Gas Engineering, Faculty of Engineering, to be assistant and acting head.
Ah, mashallah. Excellent.
Yeah,
Excellent.
this
Congratulations.
right now I'm assistant for the final project.
Congratulations.
Congratulations. Thank you so much.
Thank you. We are proud of you.
Thank you. And I'm proud today I'm listening with you. Thank you so much. If any my classmates have any question, this is our time for everything, for our attendance.
Okay. You are
Okay.
welcome.
Thank you.
Thank you.
Thank you.
Yes. Next.
Thank Mr. Samir about this answer and make this information clear. If anyone else want to ask a question, please raise your hand or write your question on the chat. Some attention here. Ask about the link of IWCF level 1, Mr. Samir. Can you provide this, please, that we can publish it on channel on Telegram?
Yes. I will show you now. 1 minute.
Okay, many thanks.
Okay. 1 minute. This one. You see it? So
Yes.
if you stop the video with you, you can take it. The video is recorded now, right?
Right.
So you can take it. And here is the email to IWCF. You can first, before you send the email, you can go into this one and read it carefully. It is 1 page only. And then you can get a tour in it and see how much is the difficulty for you. Now you are qualified to get into this exam and pass it. I am guarantee all of you. Okay? Because you have enough knowledge now.
Okay.
If you don't pass, you can try again. If you don't pass, so they will guide you. This IWCF, the procedures are here. But this certificate is very important for you because it moves you a step ahead. Today, this year, 2021, you are at level 1. It is mandatory in 2022, you are level 2. 2023, no way, you are level 3 then or level 4. So cumulative, it is cumulative, the learning. Okay, clear, Mr. Athir?
Okay, it's clear. Many thanks, and we will start from now to enter this course.
Okay.
The other question from Ismail, he want to ask a question. Mr. Ismail, you can open your mic and ask your question.
Mr. Ismail,
Mr.
unmute.
Ismail,
The other one.
I give
other
him
one.
permission, but I don't know why he don't open her microphone. Let's go to Mustafa. Mr. Mustafa, you can open your microphone.
Thank you, Mr. Athir. Assalamu alaikum. Just I have one question. Is there any way to make the level 2, 3, 4 like free? To get it
No.
like do the exam free? This is my question.
Now I have a course. Tomorrow we will announce it, but it costs maybe 5% from the cost. So you will follow me up on Facebook. You have this Facebook, I will tell you. Because most of people are not working, so $1,700 is too much for them. So if
Exactly.
you go to Facebook, you will see my name, this one. You can send me a friend request and you follow me up. I will put all posts. I will do discount. I asked the training company, Indian, maybe reduce the cost by 95%. Are you happy?
Yeah, that's great. Thank you so much for that.
Thank
Thank you so much.
And
Thank you.
5 days, same as this 5 days course, you will take, if you pass, you will take a certificate.
Okay, thank you so much. Thank you.
Thank you. Next.
Thanks. I think Mr. Ismail can't open his microphone. I give him permission, but he don't open his microphone.
3 participants.
Yes. Okay, let's go to Mr. Hamza. Mr. Hamza, you can open your microphone.
Thanks, Athir. Good evening, Mr. Samar.
Good evening. How are you, Mr. Hamza?
Thanks for the great lecture. I
Thank
have a question about flow coupling.
About?
Flow couplings.
Flow coupling, yes.
Yes, you had said that we should install flow coupling above and below SSSP.
Or upstream and downstream, or just downstream.
Exactly.
Yes.
Isn't one flow coupling upstream is enough? Upstream of the SSSP, like to face the flow or minimize erosion effects?
No, either upstream and downstream or downstream.
Why downstream? Why
downstream.
not upstream?
Why? I will tell you what are the types of the flow. You know them? Turbulent and laminar. Right? Turbulent like this. This is laminar, like line. You see my hand? While the turbulent like this. So this laminar turbulent, what will cause? It is fluid. The fluid has power, right? You hear me? Okay, I will answer. The fluid has power. This power is hitting the metal.
Yes.
The metal will be eroded. What is the difference between, you know, the difference between corrosion and erosion?
Yes, go ahead. Yeah.
Yes, the erosion, if you divert the fluid to the metal, it will be friction. This friction is erosion. While the interaction between the fluid and the metal itself, it is called what? Corrosion. Here we have, because the fluid type is changing. It is not laminar. Laminar like this, like this. So it goes. It is very friend with the metal, like this. It
Smooth,
doesn't
yeah.
cause anything. While this one is hitting. Hitting means erosion. This erosion will make the metal in bad situation. So we put it this flow coupling upstream and downstream or downstream only of the safety valve of F nipple, R nipple, SSD, other completion components to reduce the erosion to the maximum. Why? Because even if the flow coupling is eroded, but it has higher ID. I told you, same OD of the tubing, but higher ID because the wall thickness is more. Okay?
Very clear. Thank you.
Thank you.
Okay, thanks, Mr. Summer, about answer this question. I think that was the last question, and I would like to thank you about joining today with us and give this interesting and great information about IWCF, Mr. Summer, and hope to see you again on the next webinar.
You are most welcome. I will send you now the syllabus of IWCF, and you can put it in the group.
Okay, I will publish it right now if I received it.
Yes.
And okay, and for everyone, thanks for joining with us today. Hope this webinar was useful for you, and have a good night. Goodbye.
Goodbye.